In example 3b, our graph is a line. So the first thing we're going to do is determine whether or not this graph represents a function. So we're going to apply the vertical line test. So let's just go ahead and draw some vertical lines here. So here's our first one, and this vertical line intersects our blue line one time. And then let's draw another vertical line. I'm just trying to draw vertical lines in various places. So here is this red vertical line, and again, it intersects our blue line in just one point. I'll draw one more, pick right here. All right, here's another vertical line. It hits the blue line just one time. So you can keep drawing these vertical lines. No matter where you draw your vertical line, it is going to intersect this blue line in one place. So that means every input will have a single output. So this is a function. Now, let's move on to the domain and range. I'm going to erase this so we can take a better look at the x and y values here. All right, for domain, let's start there. Domain is going to be the set of all x values. Okay, we want to determine all the x values covered by this graph. So remember, to do this, we need to move from left to right. All right, so when we look at this line, notice that on both sides of the line, we have arrowheads. So basically what this arrowhead means right here, if you see where my cursor is, the line continues in this direction forever. Okay, so you can like pretend that it extends, because it does. It goes this way. You know, if we were to draw an extension here, it would go this way forever. Same thing in this direction up here. Okay, this arrowhead is indicating that this line is going on forever. This in this direction. Okay, so it just continues on. So keep that in mind. That really affects the domain and range. Okay, you've got to realize that this line continues indefinitely in both directions. So now let's talk about the domain. Okay, so if you are going from left to right, okay, so let me extend my x-axis, okay, out here. Okay, so say you were at some x value way out here. Okay, let's pretend this is pretty far out on the x-axis. Say this is negative 100,000 or something. Okay, so if this is an x value, realize that this x value is going to be in the domain, because the output for this particular x value is going to be way down here. You're going to hit the blue line somewhere. It is going to have an output. So a really huge negative x value is going to have an output. Okay, so the graph is, this line is extending over the entire negative x-axis. Okay, so if we're coming from the left, we're going to write down negative infinity, because again, the graph covers the entire negative x-axis. Okay, and we need a parentheses on that. Okay, if we look to the right, okay, again, if you're thinking x values, remember we can extend our x-axis here. Okay, if you pick a really huge positive x value, okay, pretend this is positive 100,000. Okay, you could go up and find the output for that particular x value, because the line continues indefinitely in the positive x direction. Okay, so something like 100,000 would have an output somewhere. Okay, so the graph is going to cover all the positive x values as well. So basically this blue line covers the entire x-axis. So the domain is all real numbers. As far as range goes, those are the y values. Okay, we want to figure out what y values does this graph cover. Okay, so again, we want to go from our lowest point to our highest point. Okay, so again, considering that this graph, this line extends indefinitely in both directions, you know, say because we're going this way forever, okay, this line's going down, 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 down forever, you cannot pinpoint a lowest point on the graph. It just keeps going down forever, and that corresponds to the negative y direction. Okay, you can reach negative 100,000 on the y-axis. The graph can reach negative 1 million on the y-axis, and so on. So because it's going down, 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 basically the lowest y value on the graph is going to be negative infinity. So we're going to put a parentheses there, okay? And then along the same lines, this blue line is going up, 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 up forever, okay? So you'll hit y values of 100,000 or 1 million, okay? So because the graph is going up, 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 it doesn't reach a highest positive y value, so it's going up, up, up to positive infinity. Okay, so the range here is also all real numbers. Okay, this graph, this line extends, it covers the entire x-axis, it covers the entire y-axis. Okay, so the domain and range are both all real numbers. All right, moving on to example C here. Okay, we have a rectangle. Okay, so the first thing we want to do is determine whether or not this rectangle represents a function. Okay, so let's look at the vertical line test. Okay, so I'm going to draw a vertical line somewhere. Doesn't matter where. I'll draw it right here. Okay, so basically where I've drawn it, notice that the x value here is 3, the way I've drawn this. So an x value or input of 3 is going to produce 1, 2 outputs. Okay, so x equals 3 is an input that produces more than one output here. We're failing the vertical line test, so this rectangle is not a function. Now, although this is not a function, we can still write down the domain and range for this particular graph. Okay, so let's work on that. Okay, let's start with the domain. Okay, so domain, again, like I said, is going to be all the x values. We need to figure out all the x values that this rectangle exists between. Okay, so we need to move from left to right on the rectangle. Okay, so I am going to locate the leftmost points on this rectangle. Okay, so I'm going to highlight these points, this left side of the rectangle, in yellow. All of these points are tied for the leftmost points on the rectangle. Okay, now there's actually infinitely many points in this little yellow segment if you consider decimals and stuff. I'm going to designate just a few points on this yellow segment. Like this point right here is -5, 3. This point, we'll say right here, this is -5, 1. This point right here is -5, 0. This point is -5, 2. Or sorry, -5, -2, and so on. Okay, that's just a few of the points on this yellow segment. Again, all of these guys are tied for the leftmost point on the rectangle. Now, if we're talking domain, okay, we're thinking x values. Look at the x values on all 4 of these points that I have called out. The x value is 5, or sorry, -5, okay? So basically, all the leftmost points on this rectangle have an x value of -5, okay? So that's where the domain is going to start, okay? If you're going from left to right, the rectangle starts at x equals -5, okay? And then you want to find the rightmost points on the rectangle, okay? That's going to be this blue segment. All the points on the blue segment are tied for the rightmost point on the rectangle. Okay, I'm going to do the same kind of thing. If I just look at a few points on this blue segment, this point has coordinates 9, 3. Right here, this is 9, 1. This is 9, 0. And this is 9, -2. Okay, there are infinitely many points on that blue segment if you take into account y values that are decimals and fractions. But what you can see here from just a handful, just 4 of the points here on this blue segment, every single point on that blue segment has an x coordinate of 9. Okay, so the rightmost x value is going to be +9. Okay, so the domain, let's go ahead and deal with the endpoints. Okay, so when you look at the yellow segment and the blue segment, okay, you want to know, do we include -5 and do we include +9? Well, when you think about it, okay, remember we've learned that if we have an open circle, we're going to exclude a point, and if we have a closed circle, we're going to include the point. And on this rectangle, you don't see any open circles and you don't see any closed circles. So what is going on? Well, here's what you want to remember. You want to exclude a point only if you see a big fat open circle. Okay, if you don't see a big fat open circle, if you just see a solid line or a solid curve, that is considered to be a closed circle. Okay, so if you're looking at, the yellow segment or the blue segment, we did not see any big fat open circles. We see basically a solid line. So all of these points are considered to be included in the rectangle. Okay, so we're going to end up including both of these endpoints. And also think about it this way. So like, is -5 a valid input? Well, yes. Okay, if -5 is your input, your x value, you get y values like 3, 1, 0, and -2. Okay, so it's an input somewhere. The same thing is true of x equals 9. Okay, it is a valid input or x value. It produces outputs or y values like 3, 1, 0, and -2 as well. Okay, so here is the domain. Okay, what this is saying is that this rectangle exists between the x values of -5 and +9, including those two endpoints. Okay, something else I want to mention: x equals 0 is a number inside of this interval. Okay, so here's where x equals 0. It is a valid input, okay, because if x is 0, you get outputs. Okay, so it should be in the domain. Okay, a number that is not in the domain here would be, let's see, x equals -10. Okay, here's x equals -10, if you can see where my cursor is. And if you go up and down, notice for that x value, there's no corresponding y value. So -10 would not be a valid input. Okay, so that's how you want to think of the domain here. Okay, this rectangle is existing between the x values of -5 and +9 inclusive. Okay, let's look at the range. The range, we're going to be looking at y values. What y values does this rectangle exist between? We're going to go from our lowest point to our highest point. Okay, and we're thinking y values. Okay, so I'm going to erase this stuff. Okay, so I'm going to highlight the lowest points on the rectangle here. Okay, along this bottom piece of the rectangle, this yellow part, all of those points are tied for the lowest point on the rectangle. Okay, so if you look here, if you just, there's infinitely many points on this yellow segment, but if you just call out a handful of them, this point right here has coordinates -5, -2. This is 0, -2. This is 4, -2. Oops, 4, -2. And let's see, I'll do one more. This is 9, -2. Okay, if you examine any point on this yellow segment, its y value, you're thinking range, so look at the y value, its y coordinate is -2. Okay, so all the low points on the rectangle have a y value of -2. Okay, then we're going to go up to our high point. Okay, this blue segment, all of those points on the top part of the rectangle, they're tied for the highest points on the rectangle. Okay, so if we look at their coordinates, okay, this guy is -5, 3. This guy is 0, 3. Okay, this one is 4, 3. Okay, and I'll do one more. This is 9, 3. Okay, any point you pick along the blue segment is going to have a y coordinate of +3. Okay, so all the high points have a y coordinate of 3. Okay, so again, do we include the endpoints? Well, we don't see any glaring open circles. This rectangle is basically just 4 lines. Okay, if it's a solid line, all of these points are considered to be included. So we are going to include -2 and +3. Okay, remember along the yellow segment, okay, any point on the yellow segment has a y coordinate of -2. Okay, it has those points have outputs of -2. -2 should be in the range. Okay, it's a valid output. Same thing with the points along the blue segment. All of those points have an output or a y value of 3. So 3 should be in the range. Okay, so this is telling us, okay, if this is the range here, basically the rectangle exists between the y values of -2 and +3. If you are thinking about numbers in this interval, okay, so remember range is y values. If you pick a number inside this interval like y equals 0, okay, where on the rectangle do you have a point that has a y value of 0? Okay, well, right here and right here. Okay, so this point in red is -5, 0. This point right here is 9, 0. Okay, so what you're seeing here is that there are 2 points on the rectangle whose y value is 0. Okay, so 0 is a valid output. Okay, so I just wanted to make sure you understand that. Okay, this interval is just picking up all the y values that exist on the rectangle. Okay, let's move on to example D here. Okay, here is the graph. Okay, first thing we need to figure out whether or not this represents a function. So again, we're just going to draw vertical lines here. So I will draw one right here. Okay, this vertical line intersects the blue curve in a single point. I'll draw in another one. So like right here, again, we are intersecting the blue curve in just one point. I'll do one more. I'll do it right here. Okay, so basically you can see no matter where you draw your vertical line, the vertical line is going to intersect the blue curve in just a single point. So that means every input is going to have a single output. This is a function. Okay, all right, let's deal with domain and range. Okay, so domain, okay, remember this is going to be our x values. We need to move from left to right. Okay, so again, when you look at this curve, what you should notice is that you have arrowheads on here saying that the curve extends indefinitely in both directions. So remember, this curve is going to keep going down in this direction forever. Okay, same thing on this side. Okay, this arrowhead is indicating that this graph keeps going down forever. Notice that on this side, it is not straight down. There is a bit of a slope to it. Okay, it's going down very quickly. Okay, but it is not exactly straight down at like a 90-degree angle. Okay, it is got a bit of a curve to it. Okay, all right, so keep that in mind that the graph is continuing on in these two directions forever. All right, let's deal with domain. Okay, so we need our x values. Okay, imagine that your x-axis is extending in this direction. Okay, if you were at an x value like -100,000, okay, yes, that x value would have an output. Okay, it's just way down here. Okay, so -100,000 would be a valid input. It would be in the domain. Okay, so basically, because this graph is going down, down, down forever, that means that the graph is covering the entire negative x-axis. Okay, so numbers along the negative x-axis, they always have a valid output. Okay, so you want those to be in the domain. Okay, so we are covering, the graph covers the negative x-axis, so that's going to be -infinity. As far as the right side is concerned, think about your positive x values. Say you extend your x-axis in the positive direction and say you're way out here at +100,000. Okay, you can find its output. It's going to be way, 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 way down there somewhere. Okay, but plugging in any positive x value, no matter how big, you'll be able to find its output somewhere. So any positive x value is going to be a valid input. Okay, so this graph covers the entire x-axis, so the domain is all real numbers. Okay, lastly, let's do the range here. So we need to figure out what y values are covered by this graph. We need to go from our lowest point to our highest point and write down x values, or sorry, write down y values. Okay, so basically, because the graph keeps going down, 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 we cannot, reach a lowest point, But because the graph is going down, 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 it's basically covering the entire y-axis. So you can think of the lowest y value on this curve as being negative infinity. Okay, you do reach a highest point on the curve. It's right here. Okay, and this point has coordinates 4, 6. Okay, so that's the highest point on the graph. So you need to write down its y value. The y value here is 6. Okay, so that's that. As far as whether you want to include the 6 or not, okay, remember there's no big fat open circle at this point. Okay, the curve is solid, and so you're understanding here that you should be including that point. Okay, so we're going to put a bracket on the 6. Okay, so that's telling us that this particular curve covers the y-axis from negative infinity to 6. Okay, you can kind of think of it, if you want to visualize it in kind of a different way. I'm highlighting the y-axis from negative infinity up to 6. Okay, so it would just go down, 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 down. And that's where the graph exists. Okay, if you look above y equals 6, you don't have any portion of the graph whatsoever. Okay, so again, as far as interpreting the range, this is just saying that the graph covers, it exists between all y values. It exists between, well, it exists for y values that are 6 or smaller.